Hi everyone, welcome back to the OnTrack podcast. Today we talk with Roger Paje of Simberian. Simberian makes a tool that's a 3D field solver, and it's heavily physics-based that helps measure not only traces on your board, but also materials. We recently formed a formal partnership with Simberian, and Roger and I will talk about how that impacted Altium Designer 19, 20, and what's going to happen in 21 and beyond. Enjoy this podcast. I'll see you on the other side. Welcome to Altium's OnTrack podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Well, hi, Roger. Thanks so much for joining us today on the OnTrack podcast. We're delighted to have you.
Yeah, thanks for having me.
It's good to see your face, my friend. So, for our listeners, why don't you start out by introducing yourself and your background in the industry, and then tell us a little bit about Simberian.
Okay, my name is Roger Paje. I'm the VP of Marketing at Simberian. I actually started my career quite a long time ago in EDA. There was a small startup in the signal integrity and timing space called Quad Design, and if you're long in the tooth, you probably remember that name, and if you're not long in the tooth, then you're probably thinking I'm a dinosaur. So that was quite a long time ago. That was my first foray into signal integrity, and we got acquired through a weird path, eventually into Mentor Graphics.
Oh.
I left, that was about quite a long time ago still. I left EDA for quite a while. I was playing in the telecom space. I was doing a lot of embedded designs for the telecom market. The last two companies I was with and doing designs, we were using Altium, so that gives me an interesting perspective in working with Altium.
Oh, that's neat.
Yeah, and then now I'm back in EDA and with Simberian.
Well, welcome back to EDA, buddy.
Thank you.
So, what I wanted to talk about today is that recently we have formed a formal partnership with Simberian here at Altium, and I thought it'd be interesting to our listeners to learn kind of the story behind some of the neat high-speed features that are coming out in Altium Designer. So can you talk a little bit about the partnership we've formed and sort of what the purpose of that is? Yeah,
I think it's good to start off with a little bit of a marketing principle that I learned a long time ago from a very expensive guru, that 1 + 1 doesn't equal 2 in the business world. It usually equals 1 + 1 is equal to 5 or 6. And so the partnership with Simberian, I think, kind of reflects that. If you look at Simberian, its history, electromagnetic theory developed since 2006, multiple case studies, multiple exercises with partners on validating algorithms and going through measurement versus results. And we've got a big whole library now. So we're kind of, we're very focused on that electromagnetic analysis and getting it correct. And marrying that to a PCB tool with a bunch of users, a lot of growth, and providing some accurate analysis just seems like an extremely logical decision to do.
Yeah, it sure does.
So at the top level, I think that's the thinking and a little bit of the history behind getting together here.
Yeah, well, before my life here at Altium, I worked with both high-speed digital and also had maybe 5 years where I worked on high-frequency designs in the RF microwave and millimeter wave space. And as soon as I got here and saw that some of those abilities weren't in the tool, I'm like, this tool's awesome, but it needs high speed. So anyways, I'm very excited personally to see how we're growing, with the aid of Simberian. So, because I knew early on that it was far too much work for us to start trying to code that from scratch, right? We really needed a partner
Yeah.
like Simberian, and
It takes years, trust me.
it does, right? And
Yes.
it's funny, as I was talking to experts in the field like Lee Ritchie, there's a friend of mine named Bert Simonovich, which has done a lot on copper roughness and those type of things. And every time I talk to them, I'm like, what tool are you using? And they were saying Simberian. So I'm kind of excited, like two parts of my world are coming together here. And so it's kind of
That's
fun
awesome.
to have watched that transition. So let's talk about, we got together, maybe 2 years ago. We've actually entered into a formal partnership now, but we had I don't know the details. I don't think you know either, but previous to 19, we put some things into Altium Designer. Can we talk a little bit about those things?
You mean previous to 19?
Well, going into 19, I think 19 was
okay.
the first. I think we got together previous to 19, so in the release, we put our first kind of Simberian empowered features in the tool. So
Yeah, it was the easiest point to start with the stack up manager. And so we had a field solver, and so a lot of the initial analysis on signal integrity starts with that stack up, and if you don't get that right, nothing looks right. So it's a pretty basic, logical starting point.
Okay.
In the release of 19, it was including our field solver into the stack up manager so that you can get more accurate impedance calculations on the different layers. The 19 release had some limitations on the different geometries that were possible and the number of just compounded dielectrics or other things that made it just a little bit simpler, but it was a good point to start. I think it gave a lot of people, so we were looking at 2080 at the time, right? So 80% of the users were able to use the field solution impedance calculations very nicely in 19.
And I don't think that everyone realized that the engine behind that layer stack manager was a field solver, right?
Yeah,
which is a really
yeah.
accurate way of measuring, which is very cool.
Yeah, and field solutions, the accuracy just you can't get away from it. You can't be equation based or a simplistic calculation. It has to be a field solution once you start getting into some accuracy and the frequencies that people are going towards.
Right. So we were kind of laying the foundation then in 19.
Yeah.
Okay. And then we did. Were you guys involved in the material stuff as well? It seemed like there was two features that went into 19 that were relative to Simberian, but I may be off. It may have just been the impedance calculator and the layer stack. So I guess those are related things.
Yeah. I think the material loss parameters were included in the next release. So
All
that
right.
was 20.
Okay.
Which is, I think it's still in beta.
Not for too much longer. The open beta today, this recording is happening on November 12th, and I think we have a few more weeks of open beta, and then we release or something around there. Don't quote me on that. But well, you mentioned material measurements. So can you talk a little bit about how materials come into play, in these calculations, and why it's becoming more important these days with high-speed design?
Yeah, without getting into too much theory, if you look at the roughness factors and even the characteristics of dielectrics and trying to go to material that's lower loss, it's those loss factors that are going to create problems as you go to, let's say, beyond 3 gigabits per second serial channels and maybe to 6. Really depends on the type of design, but once you start getting into those higher frequencies, which, depending on what kind of design you do, 3 gigabits per second can be kind of low or it can be kind of high, depending on who you are.
Right.
When you talk to a data center person, you're at 100. gigabits per second.
Right.
So, but if you just look at the theory, just plain theory, 3 gigabits per second is kind of that little inflection point where loss characteristics of the material start to come into play. If those don't get modeled properly, then you're looking at just simulation inaccuracies.
Right. How do those the modeling, I may be going off track here a little bit, but so don't some of the high-speed material manufacturers model that ahead of time in the form of data sheets, or how does that happen sort of inside the tool?
Yeah, it's an interesting shift, maybe in the last 2 or 3 years at least, maybe a little bit longer, where the board manufacturers have to produce data. They just have to. It's almost imperative. If you don't, the designer is going to go somewhere else.
Right.
And so now it becomes, before, when we were, in the dinosaur age, right, pre-internet, we were using FR4 and nobody cared.
Right.
You just
it
did
didn't
it.
matter.
But
right.
Yeah, it didn't matter, and everybody used the same dielectric constant, and analysis was relatively simplistic. Now you're absolutely correct. If the manufacturer of the board is not doing some sort of characterization and data that they can provide, both in a pre-manufacture and a post-manufactured case, it makes analysis almost impossible. So you get now a collaboration of EDA vendors with the designers, with the material manufacturers, and now the world is a little bit more complicated than before.
Yeah, just a tad.
Yeah.
Okay, that makes a lot of sense. So as we move now into our upcoming release of Altium Designer 20, what kind of features did we kind of build on top of once we sort of laid that foundation of impedance modeling and stack up?
Yeah. So we talked about including some of the material loss parameters.
Yes.
Those will be part of the release.
Okay.
There's also some advanced geometries. I won't say advanced, I'll say more robust.
Okay.
People who have some complex geometries like two types of dielectrics back to back, or just some of the trapezoidal geometries on embedded strip line, or even conformal coding where it's supported now. So it might not affect a lot of the users because a lot of the users may not go into things like that. But now we're starting to enter maybe the higher end of people who are doing a little bit more exotic geometries and exotic materials. So that's also supported in the latest release. And we had a few enhancements, algorithmic enhancements, and we were able to do a couple of characterization exercises to make sure that the impedance numbers that were coming out were measurable, let's say.
That's great.
So, yeah.
Would you say then that sort of as we create this synergy and this partnership that we're sort of getting ahead of where, say, your typical Altium user might be today, but most likely where they're heading?
Yeah, I'm hoping that everyone's headed in the same direction. I'm not, sorry, Judy, I'm not 100% familiar with the Altium user base. I've talked to only a few people up to this point, but if everyone's headed to DDR3, to DDR4, and onward, to any of the serial interfaces, so PCIe Express, Gen 2 or Gen 3, moving up to Gen 4, that wave is going, and most of our regular users are in that realm of transition.
Yeah. I think that from that perspective, you guys, your normal users tends to be more scientific based and further down the road than our core base of sort of the middle swath of our standard Altium users. But we're seeing more and more kick into those higher speeds. So I think that's an accurate answer.
Yeah, a couple of the product managers at your company allowed me to follow into the forums, and it certainly looks like the conversations are going in the right with the industry.
Yep.
At faster
Yeah.
speeds.
Yep.
So.
Definitely. And yeah, and that's an enabling technology. Obviously, we're trying to move towards. So what do you think the practical applications, now that we've added things for 19 and now coming out in 20? What do you think the practical impact and the importance to PCB designers will be that they might notice right off?
Yeah, I think one thing is obviously they're going to get accurate impedance and delay calculations. I mean, I think even at DDR3, skew is a big deal. But if you get to DDR4, DDR5, those impedance calculations and those skew calculations are just going to kill you if you don't look out for them.
Yeah.
So that's the biggest obvious thing that relates to a user. Is to get those numbers and to get that data accurately.
Mm-hmm. It's a big deal. I've had a couple guests on our podcast here that have talked about skew, one being Lee Ritchie, of course, and the other one was Chris Hunrath from Inselectro, right? And they are a distributor for tons of different prepregs and materials. And, he talked a lot and really taught our listeners about skew. And I had no idea what a massive impact that had on performance. It's really significant. So that is good news. Do you have any tips? I mean, you were a designer. Do you have any sort of tips for designers, as they move towards high speed? Any kind of practical things that they should be thinking about, or maybe things, being able to recognize red flags in their path?
Yeah, I have a soft spot in my heart for designers. They've got everyone on their back, right? They've got the project managers on their back, so it's time. They've got accounting on their back, so there's cost control of their design. They've got design challenges, EDA vendors who are not, producing correct results. They've got a lot on their plate.
Yeah.
And so I've got a soft spot for them. I think I'm not going to be able to tell designers anything that they don't already know. But if I was to just take a basic stab at tips, the proper impedance modeling is a big deal. You'll be able to do that in Altium Designer 20. You'll get accurate results. They've been verified against measurements. So we have a lot of confidence in that field solution. And that's a big designer worry.
Yeah.
Are my results accurate?
Yep.
So a lot of that can be eliminated with using the field solver.
That's you're right. That's a really big deal.
There's a couple other things I think maybe outside of things that people are talking about strictly related to signal integrity analysis itself. We talked about DDR4 and PCIe Gen 4, but there's also a little factor here of knowing your electrical design rules. I mean, if there's some things that I saw just yesterday, I think it was, in your layout tool, that if people know their design rules, the layout tool itself is going to be able to find different things that impact signal integrity. And the thing I saw yesterday was some of the design rule checks that you're doing with regards to return path checking. And there's a lot more to do there, but if your users know what their electrical design rules are, and to know that every trace needs a proper return path, particularly if it's a serial channel, those things can be checked, and probably the EDA vendors can improve that in the future. But that one was a big one, because analysis sometimes is hard. You got to set up the models. You got to know what all of the parameters are. Sometimes design rule checks. I used that extensively in my telecom career with the engineering teams I worked with, and they were pretty valuable. A lot of impact for the amount of time you spent on that. So.
Well, as you say, I also have a soft spot in my heart for the load that today's designers are carrying, and a lot of them being now electrical engineers, so they're handling the schematic, the layout, they're interfacing with the mechanical, the project manager, sometimes supply chain. It's an awful lot to handle, and I also talked to Alexei, who you had spoken to, that's our product manager for Altium Designer. And what got me a little excited is he said, it takes some training to read the modeling sometimes if you're just doing it, in a traditional manner. But it sounds like the way that we are building it into our tool, it will be a little more intuitive and maybe require less hardcore training to read the results and know how to interpret them.
Yeah. I had a mentor when I first got into EDA, and he was a brilliant man, and his one philosophy was let the computer do the work.
Right.
And so if we're having to have the users, as much as possible, I mean, there's still a balance there of knowing what the results actually mean, but if you can produce a piece of software that allows the computer to do the work, not the user, and a lot of that might mean just make it simpler to use.
Right.
Give me the analysis numbers, but let me know what I need to do. There have been a few ideas that have been kicked around that will probably come out in the future that will make the designer's life a lot easier in our partnership, quite honestly. So
that's great.
That'll be interesting.
Well, without giving away the plot, is there anything that we're allowed to talk about that may be coming out in, say, Altium Designer 21 or in the next release or two, or do we know that yet?
I don't think anything has been announced, but I think I can honestly say, and without any hesitation, that there's a couple of philosophies in place that we're working towards. One of them is that making the analysis easier, so you don't have to be necessarily a PhD or maybe even a signal integrity guru,
right,
to get some good, accurate results. So we're working towards making that easier. And then the second thing is, I mentioned this a little bit earlier, just the design rule checks. To be able to use a function like, and I don't want to diminish the value here, but there's a spell checker in Word, and everybody uses it. And it just reaches into a library of things, knows what's correct, and says, this is misspelled. Well, we're working towards something like that in the future for as part of our partnership, where it'd be a trace checker. And if you've routed something and it might be an ambiguous return path, or too much coupling to something, or there are a number of different geometries that can be checked very quickly. We're going to work towards producing something like that in the future as well.
Well, that sounds amazing. And I think that because you and I are both fans and cheerleaders for designers, I'm sure they'll be welcome. They'll be glad to hear, like, please take one of these balls out of my hands, right? Or one of these plates that I can stop spinning and not keep adding more and more and more. Well, thank you, Roger, so much for taking the time to at least give us a sketch and an overview of our partnership, how it's been going, and some things we can look forward to. I really appreciate taking time out of your busy day to share with our audience about where we're going.
Judy, anytime.
Okay,
it was my pleasure.
When we know more and we'll be less cloak and dagger, you and I will get together again.
Okay, we can do that.
And we'll talk about where we're going to go in the future. So thanks so much.
All right. Thank you. Bye-bye.
Okay. For our audience, thanks so much for joining us today. I hope you enjoyed this conversation with Roger Paje from Simberian. We look forward to being with you next time. Please remember to like, subscribe, and send us your comments so we know what to put on the podcast next. We really appreciate you. We'll see you next time. Until then, remember to always stay on track.